As we have completed the different aspects of entity relationship model or the ER model, let's talk about the dimensional model now. Now, all the modeling techniques give us different ways to store the data, right? So different ways of storing data gives us different advantages and sometimes disadvantages as well. For example, the ER modeling, which we've seen earlier, gives us the advantage of storing data in such a way that there are no duplicates or less redundancy, right? However, dimensional modeling, on the other hand, gives us the advantage of storing data in such a fashion that it is easier to retrieve the information from the data once the data is stored in database, right? So this is the reason why dimensional modeling is used mostly in data warehouses built for business intelligence reporting. On the other side, dimensional model is not a good solution if your primary purpose of your data modeling is to reduce storage space requirements or reduce duplicates, speed up loading time, and different factors along with these, right? So what is a basic definition of a dimensional model? A dimensional model is a database structure that is optimized for online queries, especially for data warehouses. It is comprised of entities called fact, dimensions. Now we'll talk about in more detail about facts and dimensions, but a quick overview of that is fact is a numeric value with which it can be measured. For example, the total sales, total profits, total loss, etc. However, a dimension is the reference data to it or the descriptive data to the fact table. So a good example for dimensions are, for example, if you look at it here, you have location, product, organization, and time dimension, right? So these dimension tables store records related to that particular dimensions and nothing related to the numbers or the facts or the measures, right? For example, we have taken a product dimension table. This will store the information only about the product data, like the product category name, subcategory name, product name, feature description, date, time, timestamp, right? So if you look at the other dimensions, it is the same case. Now, when it comes to the sales fact, we are seeing the measures, which are the numbers with which you can quantify on how much is the sale you've done, on what products, in which location, under which organization, at what time, right? And with these, you'll get the answers to the questions like, what are the total sales dollar value for a particular product? What is this total sales dollar value for a product in a particular location, right? What is this total sales dollar value for a product in a year within a particular location? So we are linking both of these. And you can also get the value of a product in a year within a location sold or serviced by an employee. So you're connecting your organization, time, and the location along with the product to get the total sales dollar value, right? So basically what we are trying to say here is the dimensional data modeling is used for calculating the summarized data, which is nothing but your aggregated data, right? For example, the sales data could be collected on a daily basis and then aggregated to a week level. The week data could be aggregated to the month level, which can be aggregated to a quarter, half yearly, and then an annual level. Now that data can be referred to as a summarized data or the aggregate data. Aggregation is synonymous with summarization and aggregate data is synonymous with summary data, right? So aggregation and summarization are the aspects of your fact table where you're having the measures. All right, so that's about the dimensional modeling. Now